Good evening, everybody joining us on Zoom. We're going to get started in just a moment. Thank you for joining us for Café Sci.
Thank you all for coming out tonight. We are excited to have you all here this evening as this part of Café Sci. We would like to thank our sponsors for making these events possible. So that goes out to PPG as well as audience donations such as your own. I'd like to remind the audience that following this evening's talk, we will have a question and answer session. On-site audience members will be given microphones to ask their questions, and our online audience can ask their questions via the Q&A box at the bottom of their screens. So without further ado, I'd like to welcome this evening's speaker, Dr. Claire Ebert. She is an assistant professor in the Department of Anthropology at the University of Pittsburgh. She received her PhD in anthropology from Pennsylvania State University in 2017. And in addition to her position at University of Pittsburgh, she also co-directs the Belize Valley Archaeological Reconnaissance Project, where she is utilizing stable isotope analyses, radiocarbon dating, and spatial analyses to understand Mesoamerican societies and the dynamic between these people and their environment. So I will now turn it over to you to tell us more about that.
Great. Thank you all so much for being here. I really appreciate you coming out on this rainy May day. I wish it was a little bit warmer. Hopefully I will transport you all to much warmer climates throughout the talk, since I'll be focusing on Central America, where I do most of my research. Before I get started tonight, I just wanted to give you a little bit of a roadmap about where I plan to take the talk. We'll get to the skeletons eventually, I promise. But I did want to talk to you all a little bit about what archaeology is and what I do as an archaeologist, especially since archaeology has kind of been in social media a lot recently. You might have seen a show on Netflix that I won't mention by name. I wanted to introduce you also to the society that I study, the ancient Maya, because it might be a group that you've learned about from textbooks, seen on TV, movies like Apocalypto, heard about 2012 and the end of the world. But the Maya were a society just like ours. So I wanted to introduce you a little bit more to the Maya and the sites that I work on in Belize. And then I'm going to tell you about how we reconstruct their diets. And I'll weave in themes about diet and foodways throughout the talk today. So first, I'll tell you about what archaeology is, who the Maya were, the sites I work at, and finally, what ancient skeletons can tell us about past diets. So the first question, what is archaeology? So I can't hear from those of you on Zoom, but from a couple audience members, I was wondering, when you hear the word archaeology, what comes to mind? Shout out anything. Indiana Jones, digging, yes. Anything else? Ancient people, rocks do come into play. I leave most of those to my geology colleagues typically, but Meadowcroft Rock Shelter, an archaeological site not too far away from here. It's really fun to visit, and I think they opened in April. So all of these ideas come to mind. We might think of popular media like Indiana Jones. We might think of excavation. Some people think of things like the lost city of Atlantis, which has been the focus of a recent Netflix series, and a lot of different debates in archaeology, especially about whether archaeologists have some secret agenda that we're not telling you about what actually happened in the past. I can guarantee you it's not all that interesting in terms of the agendas that we have. It's usually just to get money so we can carry out our research. Sometimes people, when they think about archaeology, they think about things like this, with aliens coming from alternate worlds to teach people how to build pyramids. Or where I work in the Maya region of Central America, we often get things like this, where imagery carved into stone by the ancient Maya is somehow translated into the ancient Maya flying spaceships and often to the sky. The image you actually see here is a sarcophagus of a king, and it shows him going up into the heavens and then descending down into the underworld. So it is kind of a celestial scene, but he's not piloting a rocket ship. So what is archaeology? Well, here's a basic definition of archaeology for you all, and I'll sort of break this down. So archaeology is the systematic scientific recovery and analysis of artifacts and features, so things that you can't carry around in your hands, to answer questions about past human societies and behaviors. So it's systematic because we follow a plan. We design research projects, carry it out just like any other types of scientists. So it's methodological, and I'll introduce some of those methods to you in a moment. It's scientific because we base many of our methods and the principles of our analyses on the scientific method, where we test hypotheses with data that we recover and then revise those hypotheses. We recover different types of artifacts. I'll show some of those to you throughout the talk today. We excavate different contexts ranging from humble households to giant temples. You'll see some images of those too. And we analyze these things both in the field, but when we get back into the lab. And I'll talk about some of those laboratory analyses as well. So even though archaeology sometimes might not seem very scientific, it actually is. And you can see an example here of some of that systematic recovery in the field. This is a picture of some excavations I conducted with my students in Belize a few years ago. We're not excavating any ancient aliens here. Instead, you can see that what we're uncovering are pots. And we're methodically cleaning and clearing around them. This is pretty tedious work. Sometimes the digging goes a little bit faster. But somebody said digging is what comes to mind when they think of archaeology. And this is the primary method that archaeologists use, excavation. And it's really amazing to dig below the ground and find an artifact that somebody last held in their hand 3,000 years ago. One reason why I love archaeology. We have several other methods that we use as well. You can see excavation up top there on the screen. Archaeologists also use methods like mapping. So we need to know exactly where we find our artifacts. So we take very detailed notes about exactly where, what coordinates things are found. You can see some students doing some detailed recording right here as well. We take the soil that we excavate and we screen it through sieves to recover artifacts, or sometimes use a method called flotation, where we use water to help us get rid of extra sediment to find not only artifacts, but ancient plant remains, ancient bones, things like that. And sometimes we don't even need to dig. We can use remote sensing methods like ground penetrating radar. That's this kind of like lawnmower looking thing right here, where you can actually peer beneath the ground in a very similar way that you would use sonar on a boat. So you don't actually need to dig to find things under the ground at all. So we have a distinctive set of methods and procedures that we use to carry out our research in order to understand and reconstruct ancient lifeways. Archaeology is also really great because it is a perfect marriage of the social sciences and the natural sciences, often because we integrate methods from many other disciplines. And you can see in a couple of examples up here. We need to answer a lot of questions about humans, their environments, their existence in the world, and we can't do this alone. So we have to draw from many other fields in order to understand humans and their lives. So some of these fields might include things like botany, zoology, so we know what animals people were interacting with, sociology, chemistry, which I'll talk about today as well. So it's really an integrative science. Another reason why I really like archaeology. It allows you to understand how people existed in the past from all of these different lenses. So now that I've introduced archaeology to you, I want to tell you a little bit more about what I do as an archaeologist. This map shows you some of the places that I have worked around the world. And I will let you all in on a little secret. I'm a child of two parents who are also archaeologists. I'm sure they wanted me to become a lawyer and or a doctor and make a lot more money, but here I am, it's their fault. And that actually opened up a lot of opportunities for me to travel around the world and experience archaeology. More recently, some of the places that I've worked have been in the US Southwest. So before coming to Pitt in 2020, I lived in northern Arizona, and I led a project for the Forest Service that trained students to look at the landscape around a feature known as Sunset Crater, a giant volcano that erupted around 1064, 1065. We're not exactly sure which year that was. But basically the eruption of that crater created a really fertile landscape with the cinders that allowed for the expansion of agriculture. So we surveyed and documented early sites around this region. I've also worked in Croatia, which is a beautiful landscape. If you've ever seen Game of Thrones, you know a little bit about what Croatia looks like. And there I participated on a project where we're interested in, again, the origins of agriculture. This time having to do with domesticated animals, sheep and goats, and looking at when herding of these animals first began in the Neolithic period, so among early farmers. But most of my work takes place in Belize, and that's what I'll spend the rest of the day talking about today. In Belize, I study the ancient Maya, and I'm really interested in the development and disintegration of ancient Maya farming communities and their responses to climate change throughout their occupational history. So I work in Belize. I'm interested in humans and the environment and how they interact. But the part of my research that I really think is fascinating and connects the past to the present is I'm interested in what people ate. Now, everybody in this room has eaten something today. Most of it was produced by farming, probably not by yourself, but maybe in a couple of cases, it was some of the food you grew yourself. But most pre-industrial societies were also powered by agriculture, just like we are. So I'm really interested in how food shaped their lives in the past. So the types of questions that I ask include things like, what types of food did the ancient Maya eat? And how do we know what types of food they ate? How did diets vary by who a person was? How did it vary by their social status, their gender, their age? We all know kids like different foods than adults do, for example. And finally, how did people adapt their diets to changing climate conditions? And this one might seem a little bit different from the other questions, but I think these issues are really important to understand in the past because we are a society who is still adapting. You can argue whether that's in a good way or not, to climate change. And a look at some recent news events, even just a few, will tell you that climate has a huge impact on modern societies. I'm going to show you a couple of examples from where I work in Belize in particular. So in September 2020, a Hurricane Nana, made landfall in Belize. You can see the large Category 3 storm as it's barreling towards the coast of Belize, which is located right here. And it resulted in the loss of hundreds of acres of crops. You can see these banana trees have been torn down. These cornfields also were severely impacted, especially in southern Belize. Now, hurricanes are getting stronger. And we often think about the water that hurricanes bring, but hurricanes also knock down vegetation that have the potential to cause wildfires for several years after the fact. So this is closely intertwined with climate change, and we can see this happening, for example, in California. Wildfires spread across the central region of Belize following that large hurricane, and burned over 22,000 acres in the Chiquibul Forest Reserve. Belize is located in an area that is often struck by hurricanes. So just another example, because I think this one is particularly visually striking. In November of this past year, Hurricane Lisa slammed into Belize and caused massive flooding throughout the country. The part of Belize that I work in, Western Belize, the largest town is San Ignacio, and you can see it here underwater following that hurricane. It is located 2 hours drive inland along a river. So even far inland, hurricanes can have dramatic impacts. This image here is from NOAA's hurricane database, and you can see that Belize is located in a region that is often hit by hurricanes. And hurricanes have struck this area prehistorically, as well as through historic times. And this image shows you category 3, 4, and 5 hurricanes that have hit the Belize and the Yucatan Peninsula since record keeping. And it's only bound to get worse. Another thing that impacts people and their food is drought. We all are familiar with this, especially in the West. Drought is a severe problem for any agricultural society. In 2020, much of Central America felt the impacts of drought. In Belize, it cost them over $50 million in crop loss. And droughts are continuing to impact people across Central America. So farmers have experienced multiple droughts since 2014, resulting in crop losses of 70% or more during some harvests. And these droughts not only impact food, they impact people's lives, and they're leaving Central America and coming to places like the United States because of climate change. So really, all of these factors are very intertwined, both in the present, and I think if we look to the past, we can see how societies address these issues, either successfully or not, to think about how we can try to address them in modern times. So the region, Central America, was inhabited in the past by the ancient Maya. And I'm going to give you a little bit of a background on the Maya now, just to introduce their lifestyles and the general region to you, since many people might not be familiar with this part of the world. The Maya lived in the southern part of what archaeologists call Mesoamerica. So this is an image right here of the Maya lowlands, and the red circle shows you where the ancient Maya, the region the ancient Maya inhabited. During the height of Maya society, the classic periods, there were hundreds of polities or independent city-states that existed in this region, and tens of millions of people lived here as well. There are two different environmental zones in the Maya region. In the southern part, the southern lowlands, it's much more lush, tropical, humid. Rainfall can average over up to 2,000 millimeters a year, so very rainy. And then there's a drier northern lowland region. So if anybody's ever been to Chichen Itza, that's a place that many people visit when they go on cruises, for example. It's located in the northern lowlands up here, which is much drier and scrubbier. The environments, though, are quite unique, even with these two kind of wet versus dry gradations. Most of the Maya region, as you can see on the map up here, lacks surface water. So there are only a few big rivers running through. Instead, people get their water from sinkholes or cenotes, which you can see an image of right here. You can go swimming in them. That's pretty fun too. They built artificial reservoirs to hold water. You can see an image right here. And of course, they did access some rivers where water was available. This region is also host to a variety of plant and animal life. So like today, most Maya people who lived here were farmers and grew and hunted their own food. Important domesticated crops include maize, beans, and squash, but other wild foods were also collected. And you can see a few examples here. This is allspice, something that you're familiar with if you're a baker. Allspice berries grow wild here. There are palms of various sorts, and a couple of other familiar foods domesticated in this region, avocados, and cacao or chocolate, which became a really important import in pre-Columbian and later historic times. The Maya only had two domesticated animals, dogs and turkeys. There were no sheep, goats, cattle, other farm animals, no horses. So most of their meat foods came from wild game. They hunted white-tailed deer, which was the primary meat choice, and other deer like this smaller brocket deer that you see up here. It's kind of like a mini white-tailed deer. Rabbits and boars as well, but also things like aquatic birds, armadillos, turtles, iguanas, large rodents, like one you can see right here, and seafood, including fish and these little snails right here called hute snails. So most of the food, at least in terms of meat, came from the forests. The Maya also accessed a variety of resources that were not used specifically to eat, but helped them cook or prepare their food as well. Local resources included things like clay to make pots for cooking and storage, chert or flint for stone tools that helped you chop or cut things, and a variety of plants and animals that were also locally available, like deer and these freshwater shells. Some resources you couldn't get in your region, so they had to be traded long distance. This includes obsidian, a volcanic glass that was the cutting edge of Mesoamerica. Literally, it's sharper than surgical steel. So this was used for everyday tasks, in addition to making things like arrowheads and other ritual objects. The Maya imported seafood from the Caribbean coast, inland long distances, so we find things like conch shells at sites. Salt was another really important commodity, just like it is today, and that came from coastal regions. And finally, tools used to prepare food, like these granite grinding stones called manos and metates, which would be used to grind things like corn into flour. So you had to have resources both locally and imported from afar in order to support yourself. The Maya are a well-known maize farming society. Corn was their primary staple. And they practiced a type of agriculture called milpa agriculture, or what we would call swidden or slash and burn. These are actually a couple of images that I was sent by my friend who is farming a milpa right now of his farm. So the milpa process begins when you cut down trees and other bush in an area and you let it dry out for a month or so. March, April, early May, the hottest time of the year in Belize, very little rain, so all the vegetation dries out. And then you burn it. And this burning releases nutrients into the soil to make it really fertile for farming corn. After a year or two of planting in an area like this, you'll also leave it fallow, and then you can come back to it after 10 or 20 years, and it should be ready to plant again. So this is actually a very sustainable way of farming. And the corn that the Maya grew looked something probably like this. This is modern corn that one of my other Belizean friends grows in his farm, and the different varieties are for different uses. Yellow corn is used to feed animals. White corn is used for human consumption to make things like tortillas or tamales. And the purple corn is used to make a corn drink called atole. So they all have their own specific, unique uses. Now, these are modern Maya examples, but we know that there are really deep histories of adaptation in this region, and farming was probably practiced almost identically in the past as it is to the present in this area. And maize farming supported the growth of giant cities in the Maya region. The Maya are really well known for things like their monumental architecture. This is the site of Tikal. Any Star Wars fans out there will also know this is Yavin 4. So that's where it was originally filmed. And they built these giant temples to house the tombs of their rulers, but also as palaces for their living rulers as well in these large urban centers. The Maya are also really well known for a lot of their scientific achievements. They had complex mathematics systems where they had a base 20 system of counting instead of a base 10 like we do. They had really complex knowledge of calendars and astronomy, as well as obviously architecture too. Perhaps they're best known, however, for their hieroglyphic writing system. The Maya had a complete writing system, which means that they could express anything in writing that they could vocalize. The writing system also integrated calendrics and is best recorded on carved stone monuments that look like this. These are just a few examples of the thousands that exist in the Maya region. And these monuments depict primarily rulers and describe the exploits of kings, queens, their marriages, their births, their deaths, their alliances, and of course, warfare between these different elite rulers who all claim divine authority. Epigraphers, people who study ancient Maya hieroglyphs, are brilliant, and they have been able to decode the glyphic system in order to understand the political systems that existed between different Maya cities. This is a recently updated, very complex chart where each circle shows the name of a different city, and the lines between them represent different types of connections, either conflicts, alliances, things like that. And this is only a fraction of what probably actually existed in the past. Of course, the Maya are also really well known for their decline. You often hear things like the mysterious Maya disappeared off of the face of the earth. Well, the Maya are still a vibrant, living culture today in Central America, but ancient Maya society did decline around about 900 to 1000 AD in the face of extreme drought, a drought that lasted over a century and resulted in rainfall reduction between about 70% to 80% of what is average, what is normal. And there were kind of two Maya collapses. One was a political collapse, where we saw the disappearance of divine kings, monumental architecture, their writing systems, and all the trappings of rulership. But eventually we also see a demographic collapse, where we see depopulation and abandonment of the Maya region. And really, populations don't rebound until after European contact. There are many, many books that have been written about this topic, but very few of them tackle the question of how was diet involved in the fall and how did people respond to climate change. So I'm going to turn now to talk about the site that I work at, to tell you how we have been reconstructing ancient diets through archaeology, both through excavations, through those methods I mentioned before, as well as through some more technical lab-based methods, primarily stable isotope analysis. And I'll get to that in a moment. But I want to introduce you to the site first and show you some skeletons, because that's in the name of the talk. The site I work at is called Café Sci, Belize. Now, this is a really beautiful site. It is an archaeological park you can visit today. You would never know it by the translation of the ancient Maya name Café, which means place of the ticks. No ticks to be found there. It was named that because when archaeologists first started surveying the site, there were a lot of cattle there, lots of ticks. Sounded terrible. Really wonderful today, though. Café is located in western Belize, so just to give you a sense of where that is located, we're right here in modern-day Belize, so we're inland, very close to the Guatemala border. It just takes about 30 minutes to get to the Guatemala border. The modern country of Belize is relatively small as well. It has a population of less than 800,000 people, which is pretty interesting. Archaeologists on my project first started working at Café in 1988, and this is what the site looked like then. This picture was taken by my co-director of my project, Jaime Awe, and I like to tease him that this is exactly probably a month after I was born, so it makes him feel very old. So this is what it looked like in my birth year. And you can see that it's still a pretty rural place covered in jungle. And this is what it looks like today. The town of San Ignacio, where Colpatch is located, has really boomed and grown, and every year I go back, it looks different. There's a state soccer stadium here now. This is a resort right up here, and the site is located just up here. But it didn't always look like this more urbanized settlement. Instead, when archaeologists first got to Colpatch, it was covered in jungle, and the site had experienced a lot of looting. You can see some examples of that here, where looters have dug trenches into buildings to find burials that they thought might have some treasure that they could sell on the black market. And they may have found some things, but luckily, looters are terrible at locating things. Archaeologists, because we're systematic, know where to find things that can help us answer our questions. This is another image of the site as it started being cleared. In the early 1990s, a project called the Tourism Development Project, or TDP, directed by my co-director, Jaime Awe, started to work to consolidate the site for tourism, because it's located in a town. So you can see some people clearing off the buildings here, excavating, and eventually it ends up looking something like this, where once we know the form and shape of buildings, we can, in a sense, glue it back together, so you can see what it might have looked like, in part at least, when people lived there. This is the royal palace at the site, and this is probably the ruler's throne room, which is pretty cool. A couple more pictures of what the site looks like consolidated. This is an entrance into that palace area, and then the main temple at the site is located here in a large open plaza, and you can see some of my students being very diligent and excavating right in front of that building. But based on our over 35-ish years of work at Colpatch, we know about its history in quite a bit of detail. One of the buildings that has given us the most information is this building right here. Looks pretty unassuming. It's called Structure B4. But archaeologists put a unit right down in the top of the building, and they dug, you can see down here, that unit, they dug over 7 meters down, so 7 times 3, 21 feet, pretty deep. And it showed over 13 different phases of construction. So what archaeologists do when they dig down like this is they peel back different layers like an onion to get to the inside, which is the earliest phase of occupation. And what we know about that earliest phase of occupation is that people who lived there, lived in very small egalitarian villages. So around about 1000 to 900 BC or so, a period that we call the early pre-classic. The houses probably looked much like this modern Maya house here, and we don't really have a lot of evidence for inequality. Nobody had better items than somebody else. Nobody had a larger house. Most people, however, did have imports from long distance away, including seashells from the Caribbean coast used to make beads, and obsidian from the highlands of Guatemala as well. We also know about everyday life from pottery. This is the bulk of what we find as archaeologists. And pottery is really great because it can tell us about diets in the past. So pots often look like this. We have big, large storage vessels used to probably store water, smaller little vessels, storage here. But we sometimes find these specialized vessels that kind of look like something that you probably have in your kitchen to strain pasta, a colander. So these are large pots with holes poked in them, and they can drain water through. Now these colanders, as you can see, have this residue on the inside, and they were probably used for processing something we call niche tamal. Niche tamal is lime-treated maize or corn kernels that are soaked in lime. Hominy might be very familiar to many of you, same thing. And these colanders would have been used to kind of strain that corn that then could be ground up and made into various different foods. So this in part tells us about what people were eating. They were treating their corn with lime in order to grind it up before processing. We also find pottery that is a little bit fancier, not in as large quantities or in as large fragments. This pottery is some of the earliest pottery from the region, and you can see the decorations on it. These cross symbols, little etchings in here. And these pots probably were much larger vessels, so it would have been used in community events or feasts. Now, the later classic Maya actually drew these scenes for us, so we have an idea of what they looked like. And they might have looked something like this, where we see people sitting around a really large bowl full of food, sharing it together. Now, most of these depictions are probably pictures of tamales. These are the tamales you might be familiar with, some type of corn dough or masa filled with food. They typically are now steamed in banana leaves in Central America. So some type of palm leaf or maybe corn husks, but made out of corn dough. We don't actually see evidence for tortillas until much later, when large flat ceramic discs called comals, or basically griddles, are made. So people are eating corn in the form of tamales, and you can see they're really enjoying it. After this early period, we do see evidence of social change at Calpech, however. Some of my excavations in some of the large public plazas have revealed early architecture just below the surface. You can see the kind of facade of this very large building that we excavated in 2017 and again in 2018, revealing the footprint, more or less, of this very large building that measured about 16 meters by 20 meters. And you can see one of my students there for scale, pretty big building buried under the ground. This building articulates directly with this larger building at Calpech, structure B1, which is the largest temple we have there. Excavations of this temple have revealed at least 13 royal tombs, including the earliest royal tomb at the site. And we know that it also houses the latest burial at the site, which was probably the interment of an individual around 900 AD. So a long sequence of royal dynastic burials as early as about 100 AD. So how do we know that there are tombs in this building? Well, you go down from the top. So this is an image of some of the excavations that my colleagues conducted in 2011 at the very top of this building. I do not envy them. This is a little scary. And they poked a large unit in the top of this building, and they were able to reveal some of these burials. Now, I'm gonna just share the earliest royal tomb with you, because it's gonna kind of set me up to show you differences in diet later on. So this is an image of excavations of that tomb. It was not incredibly well preserved, but some really amazing items came out of it. But I did want to show you what that excavation looks like. So you can see two of our Belizean colleagues here excavating. You can see some pottery up here. The bones were really poorly preserved in this burial. Here's a drawing that makes it a little clearer. We basically had a femur, and that was about it. But based on teeth that were present in the burial, we know that the grave contained at least 3 individuals. And these individuals have been radiocarbon dated. It turns out they lived at different times, so this tomb was actually re-entered to inter people. But the earliest burial is the burial of a female, adult female individual, and in total there were over 120 objects in this tomb. And I want to show you some of those objects because they're pretty incredible. Some of them look like this, these beautifully painted pots. We know that they also date to a period called the Early Classic based on their form and style. Some are painted and slipped and fired, and one right here is a very rare example of a pot that is stuccoed and then painted. And those colors you see on that pot are what was preserved. So we have blues and yellows and reds. This is very unusual for the Maya region. Jade is also very common in elite burials, and we found a lot of jade in this burial, including ear spools, which are at the top, so for gauged ears. You can see 3 different sets of those actually. Large tubes that would have been used for necklaces, and this little jade pendant guy right here. Now, jade is really interesting because jade is green. It represents life, birth, and is also associated with the maize god. This little guy probably represents the maize god who many rulers styled themselves after. So rulers, ancient Maya rulers, actually connected themselves then to farming and productivity and corn. A couple of other amazing things we found in this burial included ceramic rings that are inscribed with hieroglyphs that probably list the name of the person who wore them, shell beads, and finally at the top, this shell ink pot that still had pigments preserved in it, including blue, red, yellow, and black. Again, pretty rare. Now, these early kings at Kalpech oversaw the expansion of their kingdom, and we have archaeological evidence of this as well, which also tells us about what people were eating. A key component of these growing hierarchies for the classic Maya was agricultural intensification and increasing reliance upon maize as a staple crop. We can see that in infrastructure that people were building. These images you see on the screen are revealed by LiDAR, or light detection and ranging technology. LiDAR is collected when planes, this is airborne LiDAR, planes fly over an area, shoot laser beams down that go through the canopy. That allows us to get a very precise 3D image of what's on the ground. And we can kind of peel the trees back then and see the ground surface. Our work has shown that the Maya intensified agriculture by creating water management features like the ones you can see up here. I have walked all of these blue lines, these ditches. There are over 11 kilometers in this small area. I've mapped them all. And also agricultural terraces that would have been used to hold in soil so people could even farm on steep slopes. We've ground truthed these, so we know that the technology is just not showing us what we want to see. We've documented these through archaeological survey, which in Western Belize isn't always in the jungle. Sometimes it looks like walking through cornfields. Or sometimes you have close encounters with some cows. This image I am showing you too, because this hill in the background might look pretty unassuming, but that's actually an ancient Maya site. That's an ancient Maya household right there, a mound. We've surveyed all of these areas around Kalpech, and this image is a map of where all those sites are located. And we found burials at all the locations that are marked by a yellow star. So not only do we know what elite burials look like, we know what the burials of everyday average people look like as well. So I'm going to show you the burial of one individual from a site called Tsutsikin, roughly translating to sunset in Yucatec Maya because it's located west of Kalpech. I carried out excavations here for my dissertation research in 2014 and 2015. Excavations of one of the largest buildings revealed this kind of altar stone, and behind that was the burial of an individual that looks very different from the burial of that high status individual that I showed you before. So you can see that we have a little bit more preserved here. The cranium is right here, not very well preserved, but the long bones of the leg, the femur, the tibia, the fibula, were preserved in this individual. There's only one item that was buried with this individual. You can see it placed in the area of the pelvis, right here. And this is what that burial looked like. This is a little pot in the shape of a frog. This is probably, people always ask me, what's your most favorite artifact you've ever found? This is probably it. He is in motion. You can see him jumping. So this burial is very different. So this leads us to that next question that I'm really interested in. Beyond what they ate, how do we understand differences in diet between different social groups? And this is where isotopic or molecular analyses come into play. So a lot of this information I've shared with you so far is from the field, and now we're going to move to the laboratory to learn a little bit more about what people ate. A lot of the work I do at the University of Pittsburgh deals with stable isotope analyses. So this is chemistry and not necessarily methods that archaeology has developed on its own. So the first important thing to know is, what is an isotope? So simply put, an isotope is a different form, there are two or more, of the same element that contain equal numbers of protons but different numbers of neutrons in the nuclei. So basically, they have different relative atomic masses, but similar chemical properties. So carbon is an element present in all living organisms, and there are 3 isotopes of carbon. Carbon 12, which is the most abundant form of the element, carbon 13, and then carbon 14, which is the least abundant form. Carbon 14 is actually radioactive, so it is not a stable isotope. It changes into a different element. We're primarily interested in the stable ones for today's talk. The other isotope that I am primarily dealing with is nitrogen. Nitrogen has 2 stable isotopes, nitrogen 14, which is the most abundant, and then nitrogen 15. Now, what we do in stable isotope analyses is we measure the amount of different isotopes relative to each other in a sample, in essence. And this type of molecular approach can tell us a lot of different types of information. I mentioned radioactive carbon or radiocarbon. This element changes into nitrogen at a known rate, which can reveal when an individual died. We don't have time to talk about radiocarbon dating today, but another thing that we do in my lab. What we will focus mostly on is carbon and nitrogen stable isotopes in bones that can tell us about averages in people's diets in the last 5 to 10 years of your life. Your bones are constantly growing in your body, so the bones you had as a child are not the bones that you have in your body right now, but we're able to get a glimpse of diets through carbon and nitrogen atoms in bones, showing us what people ate kind of at the end of their lifetime. Another isotope that we can look at is strontium. I won't also have time to talk about strontium isotopes, but strontium in enamel can reflect where a person was born and grew up, because it reflects the geologic signal of the food, the water that you ate from a particular region. So I can look at somebody's enamel and say that they grew up in Pittsburgh versus they grew up in Florida, for example. And finally, oxygen isotopes, which come from lake cores or cave formations like stalactites and stalagmites, can tell us about relative amounts of precipitation or temperature. So molecular archaeology is actually really powerful because it can answer many questions in addition to what people ate in the past. We look at all of these different isotopes at my lab at Pitt, the Tropical Paleoecology and Isotope Geochemistry lab. You can see a picture of the empty lab right here. I should get a picture of a lot of people working very hard. They do. One example of a student who is sampling bones. We put bones through several different types of chemical processes in order to extract bone collagen, that part of the bone that makes it kind of bendy and flexy. So not the mineral portion, but the organic living portion. And that's what we analyze in order to understand what people ate in the past. So I mentioned that the stable isotopes, carbon and nitrogen, reflect the types of foods that you've consumed in the last 5 to 10 years of your lifetime. Stable isotopes are very powerful as well because they are a direct measure of what people are actually putting into their bodies. We can examine ancient pots, ancient stone tools, we can look at animal bones, we can look at plant remains, but those might be used for different things, and they can't necessarily reflect what an individual person was eating. Isotopic analyses, your chemical signature in your bones is unique to you. And we all have food preferences, right? And so we can actually reveal that. We can look at unique individual diets that can tell us about someone's social status, their political status, or their economic identity, in addition to things like age and gender identity as well. Plus, they can also tell us what types of resources people actually had access to at a broader scale. I'm going to briefly talk about the isotopes that we study. The first one, like I mentioned, is carbon. Carbon isotopes reflect the different types of plant proteins that we consume. And most of our protein, even if it's coming through animals, is from plant protein. There are two primary types of plants that we're interested in, C3 plants and C4 plants. They have different photosynthetic pathways, they photosynthesize differently, and they result in different amounts of different types of carbon isotopes in bones. So C3 plants include things like wheat, rice, potatoes, and soy, but also wild vegetation, trees, shrubs, especially in temperate zones. So most of the plants in Pittsburgh, C3 plants. These will have lower carbon isotope values, ratios of that carbon 13 to carbon 12. On the flip side, we have C4 plants, maize, for the Maya, very important, but also things like millet and grasses in hot, humid climates. And of course, maize was the most important C4 plant for the Maya. So if we can track values of carbon that are extremely high in people's bones, we can tell if they ate more corn or not. And we plot these values on what we call a diet space. It looks something like this, with carbon isotopes on the x-axis right here. So you can see that plants, you can see that when an individual has lower carbon isotope values, they're eating more C3 plants. They're kind of on the far, that's your left side of the screen. And then if they're eating more C4 plants, they have higher carbon isotope values. The other type of isotope, nitrogen, we're interested in. Nitrogen reflects the types of meat protein you're consuming instead of your plant protein. And this varies based on the trophic level or the levels of the food chain. So nitrogen values are very low in plants, but will increase in herbivores because they're eating plants that have nitrogen, so it gets compounded in the herbivores. Omnivores who eat plants and animals also intake more nitrogen, so their nitrogen is compounded again, so they even have higher values. And then marine animals, which have more levels of the food chain in marine ecosystems, they have the highest nitrogen isotope values. So plants are at the low scale, and then animals that eat animals, carnivores, up at the top of the food chain, have the highest nitrogen values. And again, we can plot these on our diet space to understand what animals and people are eating. So it'll look something like this. We have our C3 plants and our C4 plants on our carbon axis down here. And on our y-axis with the nitrogen, we have our herbivores, omnivores, carnivores, and finally our marine mammals and fish. So we can plot individuals ancient people on plots like this as well. They might be corn lovers, and so they fall somewhere over here. They might be vegans and only eat pumpkins, and they fall somewhere over here. So we can actually compare individuals' diets in this way. So I was really interested in understanding diets between the haves and the have-nots. Did kings and queens have different diets than your everyday average people? So the way that we addressed this question was by actually looking at the stable isotopes in people's bones from these different contexts. So we had a relatively large burial assemblage, and we were able to link social and political values with diet choice. We did this by assigning people to monumental or ceremonial contexts. These are people who are buried in tombs or other special contexts in temples and palaces. So these are the rich people. They're the royals, they're the elites, they're buried in the fancy areas. And we could compare these to people buried in residential areas. So people buried in simple graves, probably close to their houses. They might not have many grave goods. These were your everyday average farmers. So we were able to assemble a relatively large data set from over 75 individuals. And I want to share that data with you now so we can really assess who ate what in the past. We also know when these people lived based on radiocarbon dating, so we can plot them on a timeline. This is earlier in time, this is later in time, just for your reference. So this is just an image of carbon isotope values for early burials at Kalpetch. And they're indicated by either open circles, which are your everyday farmers, they're buried in the settlement zones, the residences, versus your elites who are buried in monumental architecture. Those are the closed symbols. We had a lot more people from the settlement dating to this time, but one thing should stand out is that in terms of their carbon isotope values, elites had much higher values on average. There's just a couple of them, but they're eating more corn. We can also look at their meat consumption, right? We can look at their nitrogen isotope values. Again, the closed circles, the elites are higher on this scale. They're getting more meat or marine protein. So already we can see that people had different diets based on their status early on in time. Now, this is a smaller data set. For the later period, we have a much larger data set. But what we can assume based on these data here is that people ate a variety of different types of foods. Elites are eating more meat and more maize, but people are kind of all over the spectrum, which suggests that they're eating domesticated foods, but also getting a lot of wild resources as well. This is great because during times of climate stress, wild resources are more reliable than farming corn. So people had fallback foods in case of different types of environmental stressors. They were eating things like deer, palms, and also, this is one of those snail shells, but a giant one. Another cool artifact I found. I'm going to share now the larger later data set with you, and it's going to look like an isotope party. It's going to look like confetti, but I'll try to break it down. This is just corn consumption again. So the colors represent different time periods, but what I want you to sort of see in this image is that the closed shapes, the closed symbols, are still on the upper end of the scale. These people are still eating a lot more corn, consuming more C4 plants compared to your everyday average farmers. Now we can also look at the meat consumption again for this larger data set. It's a little bit more variable, but on average, they're eating more meat protein as well. And these are kind of the averages for the royal and elite diets. Their average carbon values fall somewhere in here. So that's representing a lot of corn in their diet, like predominantly corn protein. And then they still have pretty high nitrogen values as well. So they're eating a lot of meat. Now I showed you those two different burials from Kalpech. I showed you the first, a burial from the first tomb of rulers. It's an adult female. And then I showed you one from the settlement with that little frog pot. I'm going to show you where these people are located on these charts. Okay, so that first burial I showed you, an adult female, elite individual, very high corn consumption, very high meat protein consumption, the highest that we have for the elites, in fact. And then this is the burial that these are a little bit off. It should be pointing to this one right here. This is the burial of that individual with the frog pot from the settlement, so the non-elite burial. And you can see that their diets are very different. They're eating a lot less corn, so probably more forest foods, more C3 foods, and a lot less meat protein as well. So the question is, what were the elites doing? Why were they eating so much corn? Did they just really like tamales? Well, maybe. But we also have some more clues from the depictions the Maya left themselves. So we know that at Kalpech, at least, by the Classic period, by 300 AD, the elites had this very maize-focused diet. But it might not just be from solid foods. In fact, some of the iconography that we get from classic Maya vases, so these are vases that are like this, that are then rolled out, the images you can see, they're probably drinking their corn, as a lot of us may have done before the talk today. So you can see here, for example, maize beer bubbling, fermenting in vats below the scene of this ruler sitting on his throne. And then there's this smaller individual here who is drinking a big cup of that chicha, that maize beer. This is also up here, one of my personal favorites. This is a scene called The Drunkard. It's that guy at the party that is falling over. He's had a little bit too much to drink. That's what these glyphs actually say. And his friends are helping him home. You can see the female attendants over here on the side, again with a big jar of chicha. A lot of elite individuals among the Maya had modified teeth. They were filed and shaped and inlaid, so they drilled out the front of them and inlaid them with jade, obsidian, other types of precious stones. It would have been very difficult to chew solid foods, so drinking your calories would be a great alternative. We have not tested isotopically or otherwise at Kalpech whether this is how people were intaking a lot of their maize, but these scenes provide us a few clues. But I mentioned to you earlier on that the Maya overall faced a period of decline at the end of the Classic period. So eventually this all came to an end. And this leads me to the last question that I'm interested in answering. How did people adapt their diets to changing climate conditions? This has been a question that has been important for people since they began farming food. I'm going to show you just a couple more graphs. There's a bunch of squiggly lines, but I will break them down for you as well. So these lines here represent paleoclimate data sets. These are from two different areas of Belize, both from stalagmites from caves. They record relative amounts of precipitation. The most important thing to keep in mind for these images is if there's a point that's going up, it means it's wetter. And if it's a dip that's highlighted in orange, it means it's drier. So there's a drought. And I've actually highlighted the two major droughts for you with that kind of beige color in the background. And you can see at the end of the Classic period, this second highlight, there was a really severe long-term drought. We can plot isotope values against these droughts, these records, because we know when these people lived. And I'm just going to share the carbon isotope values with you that reflect corn consumption, since corn would have been most impacted by adverse climate conditions. What you see here are averages per time period for elite burials in this kind of pinkish color, and your non-elite everyday average Maya burials in this green color. The trends I want you to notice are how these shift over time. Now we see an increase in maize consumption generally, more C4 food over time, not surprising, we kind of already knew that. But there's a kind of a more subtle pattern that you can pick out here. And it looks something like this. So we see an increase in maize consumption until we get to the end of this wet peak and things start to dry out. And we can see carbon isotope values that reflect maize consumption track that drying trend. We can also see that for our non-elite residential burials, although they are still in general eating less C4 plants, less maize than your elites. So there's a shift in carbon values, a shift in maize consumption corresponding with drying climatic conditions as early as 600 AD, which is pretty interesting to think about. So what do I think this all means? How do I interpret what these skeletons are telling me about what people ate in the past? These isotopic results, in addition to the archaeological information we have, suggest that people, especially early on, had really diverse diets. They ate domesticated foods, they exploited wild forest resources, they harvested things from fresh water. And these probably were great resources, especially in times of climate stress, where you could tap into local vegetation, local flora, local fauna to get through drought conditions. We see decreased maize consumption, like I just showed you, as early as 8600. And this is evidenced by decreasing carbon isotope values. But this shift also suggests other types of accumulating stressors. It can't just be slight drying of the climate. It suggests instead that there are different social, political, and economic stressors at play as well that may have impacted food resources. One of these could be elite demands for maize. We clearly saw that they love their chicha, so they are definitely not the ones who are growing the corn either. So they were taxing local populations and getting corn from their the rural hinterlands. We also see things like population increase in general and landscape degradation in the face of agriculture. So these things probably resulted in what we might think of as a less resilient system. The Maya may have been caught in what is called sometimes a rigidity trap. This is when a system becomes so highly connected and self-reinforcing and inflexible that they have no options to adapt to changing climates or other types of changing circumstances. They basically fail to internally reorganize, whereas people earlier on with more flexible diets were able to do so. So the title of the talk said, what can ancient skeletons tell us about past diets? But I think ancient skeletons can also tell us about our future. And that's what I will wrap up with today. So looking at the role of diet using traditional archaeological methods like excavation, artifact analysis, but combining it with molecular methods allows us to assess things like resilience and vulnerability, things that we're really concerned with right now, things that can tell us about how agriculture can respond to climate change in the past, but also the present. Stable isotope data show us that diets appear to expand in times of environmental crisis when possible. This is true of the early people at Calpetch. But as systems become more interconnected, they are not able to adapt as easily. So the take-home message from this, I feel, is that the resilience and adaptability of environments are critical issues that we can learn about from the past. We can see that in times of stress, if we can expand our diets using local resources, we can mitigate that environmental crisis. But as we become more connected, more dependent on mechanized agriculture and its production, this makes us less resilient and less flexible when there are things like climate stressors. So I think in the end, we can really take a cue from the past, learn from this long, deep history of archaeology to potentially mitigate for similar climate shifts that are happening in the present in our increasingly interconnected modern world. So you really are what you eat, and we can learn from the past. Thank you. I am happy to take any questions. I will quickly, though, acknowledge that archaeology is a group endeavor. So these are all the people who made a lot of this research possible. And any questions, happy to answer.
Hi. The question I have relates to the well water that I have at my home. It is very hard water.
Okay.
And I have asked doctors and people in the past, am I getting any dietary benefit from that hard water, which has a lot of calcium? And so now I guess I would ask, would that show up in my bones if you were to analyze my bones today?
So it probably would. We would use slightly different isotopic analyses to look at that. So instead of looking at the bone collagen, which is that organic component, we would look at the apatite minerals, which are the mineral component of your bones, which are primarily made up of calcium, but other things as well. But interestingly, your calcium would look very different from the calcium that you consume in your diets, right? Because a lot of our salt does not come from our backyard, right? We're importing it and buying it at the grocery store and putting it in our food. So it could potentially show up in your bones as kind of a local source of calcium. You would need to be consuming it for very long term though. So decade plus for it to show up. Probably likely, people stay in their houses. So it is possible. Health benefits, I am not an expert on that, so I can't tell you anything, but it would, we could probably detect it in your bones. We can also do things, interestingly, like analyze hair. Your hair grows incrementally about 1 centimeter every month, or maybe more if you're very lucky. And we can look at changing diets in hair or fingernails as well. So, you know, if your friend is like, yeah, I'm a vegan, you can actually test that by looking at the isotopes in their hair to see if they're lying to you or not.
So during the drought that caused the demise of the Mayans, was there any evidence that they were able to address that by migrating to some place that didn't suffer as much from drought?
Yeah, that's a really great question. So large-scale studies of strontium isotopes, which can detect migration, it basically can tell you if you are buried in a place with a different geological signature than where you were born, show us that people moved from the southern Maya lowlands during this crisis up to the northern Maya lowlands. So even though it's drier up there, we actually do see large-scale migration and booms in urbanism at cities like Chichen Itza and other post-classic Maya cities that probably were being supplied in large part by trade from coastal routes. They're much closer to the coast. So large canoes coming with trade goods to feed people. So people did move to different places. There were probably other things at play too, though, like disease and famine, which can really amplify during droughts. We know about this in northern Mexico during the colonial period. People wrote about droughts that caused plagues of locusts and then resulted in famine and disease and high mortality. And we can actually see this in wills. They increase through time, which is a little morbid, literally. But people did move, to answer your question, but sometimes they were hindered by other impacts of droughts that were kind of feedbacks from that climate change.
I was also very surprised that you said that, and this must have been at the height of the Mayan civilization, have like 10 million living in that area, is that right?
Estimates vary, but anywhere from a couple million up to 20 million, depending on who you ask and how they calculate it. But there were pre-contact millions of people, tens of millions of people living throughout Mexico, Belize, Guatemala, and northern Honduras.
You know how that compares with the current population density in that area?
You know, that's a really good question. I've never actually, I should do that. I've never actually done a comparison of modern versus ancient populations. That'd be a pretty neat comparison though. Maybe I will do that. I'm sure somebody else probably has, but.
Hi, I'm a chemist, so I'm up here. So
Okay.
I'm a chemist, so I don't know much about it, but I always thought photosynthesis was like one process, and you mentioned there are different kinds. How do they vary, or what's the difference from a basic level?
So that's a really good question. So there are three kind of, to my understanding, I am not a botanist, but to my understanding, there are three different ways that plants can photosynthesize. They can follow a C4 pathway, a C3 pathway, and there are also cam plants that kind of switch in the middle of the process. I didn't mention those today, but those are primarily succulents, cacti, things of that nature, that end up having carbon isotopes that are in the middle between C3 and C4 plants. The exact processes, I cannot describe to you, to be honest, but there are those three different pathways that result in those differing values, at least in people's bones. They actually, archaeologists have also done studies on the plants themselves and their different carbon values based on those different photosynthetic pathways too. So it's transferred over into humans when they consume those plants.
So just a quick follow-up, is that
Yeah.
just a difference in the ratio of the C13 to C12?
Exactly,
So
yes.
that 1.11 C13
It can
is
make a
like 1 and
difference.
1.2 or something, or?
Yeah, it depends, but yeah, so it's a small difference. The ratios to get the calculations, which I didn't share with you all, you multiply the ratios times 1,000 to actually get a value that is meaningful. So.
Thank you.
Yes, yeah.
Are there ethical or cultural concerns of this type of archaeology?
That's a really good question. It depends on the region that you work in. So in North America, there are quite a few concerns, especially from indigenous and descendant populations with analyses of human remains. On our project, prior to doing any types of analyses, we consult with local descendant communities about the work. We ask them what kinds of things they're interested in knowing about the ancient Maya, how they feel about excavations, analyses of human remains, things like that. And people are actually really quite enthusiastic about it. The culture is a bit different in Central America compared to North America. Excavations of human remains are not necessarily seen in the same way, partially because while many Maya individuals recognize their descendant from the ancient Maya, there's not a direct tracing of a lineage. And in general, part of the process that we go through for our analyses also has to do with different governmental bodies that we get permission from as well in Belize. So unlike in the United States, Belize and many other Central American countries have government bodies or institutes. The Institute of Archaeology, for example, in Belize, which oversees heritage and archaeology. They give us permits to excavate, but also to do analyses. So they have to give us the final sign off. And all archaeology in Belize is part of national heritage. It's not seen as necessarily one group's versus the other groups. It's part of the heritage of the entire nation. But we do undertake that consultation process in order to make sure people are okay with us doing that research. If they're not, we won't do it. But by and large, people have been really enthusiastic and excited about this type of work. They find it really interesting that the ancient Maya also ate corn, and they want to know more about their life ways and their habits that we can learn from studying human remains in particular. That's a great question. You're welcome. She's getting her steps in.
Several times during the Q&A, you've mentioned that's a very good question.
Yes.
Here's one that you're likely to say, that's a very boring question.
We'll see.
But being a speechwriter, my question, interestingly enough, has to do with grammar. So there is Mayan, singular, Mayans, plural, then you use Maya. What is the difference? How does Maya fit with Mayan and Mayans?
Yeah, so the word Maya refers to the people and the culture. So the ancient Maya, the modern Maya, a Maya house. Mayan refers to just the language. So Yucatec Mayan, they spoke Mayan, Mayan hieroglyphs. So everything except the language is Maya, and Mayan with the N is referring specifically to the language. That's actually what I start off teaching when I teach my section on ancient Maya in my Mesoamerica class. So.
I'm just curious, you mentioned that the more affluent Maya were disproportionate consumers of maize and perhaps disproportionately consumed that in liquid form because they were unable to eat it. They are also, however, disproportionate consumers of meat. So I'm wondering how that worked.
Yeah, so there's a couple of ideas about that. And I will mention this is a case study from one site, but I'm working on a really large project now where we're collecting all published stable isotope data from the entire Mesoamerica region, so Mexico through Honduras and the Caribbean. And these patterns generally hold true. So we have thousands, over 7,000 data points, which is a lot of spreadsheets to deal with. But it seems like, based on excavation, so of plant remains and animal remains, high status, elite, affluent Maya are more likely to have higher proportions of large mammal bones in their trash, what we call middens. So they have large cuts of meat compared to your everyday farmers who we typically see lower proportions. At least in the area that I work in. So they're still eating meat, but maybe not quite as frequently. And we do see some marine fish in the trash of the affluent Maya. So they're importing fish, probably salted. I've seen some arguments that they made some weird aquariums and were bringing them in. I don't know about that. But they were bringing in fish from the Caribbean coast, which can account for those higher nitrogen levels, so that higher protein intake. So this could be evidence for the more affluent folks tapping into long distance trade and exchange networks that your commoners didn't have access to. And we know that was true for other types of resources, pottery, obsidian, things like that. But also evidence that these higher status individuals may have controlled access to local resources like local forests. Think, you know, medieval Europe, where people would not let you hunt in their forest because, you know, it's the king's forest, for example. So that's hypothetical. I don't have evidence for that, but we do see these higher proportions of animal bones typically in these high status contexts compared to lower status. So we know they are generally consuming more of it. Could be in a feast, could be just because they're rich and they can do it. So they had, you know, access to more resources locally and further afield too.
We've got a few questions from our online audience.
Okay, great.
We've got a pair of questions here from one of our Café Sci stalwarts, Kitty Mama. And Kitty Mama noticed that colorful shirt that you're wearing.
Oh, yeah.
And later on, it appeared maybe to my eyes that, you know, it was a peacock, but then I saw some of the turkeys that you showed in the, so is that like a depiction of a turkey, or is that related to your talk tonight?
So I decided to wear this shirt last minute. I was just like, aha, right before I left the house. This is from Merida, from Yucatan. It's a huipil, so it's a hand embroidered shirt made by a Maya artisan. So I mostly bought it from Sunflowers. It could be a turkey. I never thought of that before. I just thought the colors were pretty, but I thought it would be particularly apt for this talk because animals, flowers, but also because it is a great opportunity to wear something created by a Maya artisan. So that's why I chose this shirt today. I'm glad somebody noticed.
And the more hard-hitting question here.
Okay.
You said that both of your parents were archaeologists. How did you become interested in ancient agriculture and diets?
That's a great question. So I first started studying the ancient Maya, at least, because as an undergraduate, we had to go on an archaeological field school. There were a couple of options. One was stay in New Mexico, where I already lived, and I wanted to go do something fun. I was like 18, 19. The other option was Hawaii, and I was like, yeah, that sounds awesome, way too expensive. So Belize was less expensive, and I went down there in 2008, and I've been going every year except the pandemic since then. So it's like my second home. I was originally interested in studying large-scale spatial analysis, so using geographic information systems to look at how people place their settlements on the landscape in relation to things like good agricultural soil, water, springs, things like that. But as a graduate student, I worked in a lab that is very similar to the lab I worked in now. I had zero chemistry background. I didn't know anything about isotopes or molecules. I mean, I knew just like the bare bones to get through college, right? But I got the opportunity to actually work in a lab like this, learn all the methods. And I found it really incredible that once you're actually in that setting, it makes so much more sense than reading a paper about it. So you can actually see the chemical reactions happening. You can see the steps along the way, and then you get the data and you get to analyze it and interpret it. So it was a little bit by chance that I was interested in agriculture and diet because I was thinking broad scale first, right? Like, how are ancient cities structured, and where did people live and why? But this actually gave me the complete flip side, where I could look at the smallest level about an individual and their diet choice. I will also say I really like cooking, so that probably helped as well. I also like eating. I'm sure many of you do as well. So that kind of really helped me kind of narrow in this focus. I thought it was just like amazing that I can understand how, like, an individual who didn't like a certain food, or somebody who was a young child who was weaned on something. You can really get at the individual lived experience, which I thought was really neat, a different perspective that we don't always get in archaeology because we can't talk to people, right? They're gone.
A societal question there. You had the map up there of the different, should I call them city-states, or were they just cities there? And all the relationships between them.
Yes.
How did they get those? Are there that many glyphs around that they could read them and say, yes, we hate those folks there and we love the people on the north side or something? And
yeah, so they're primarily, about the rulers, right? And there are thousands of those carved stone monuments. There probably were also a lot of books, bark paper books or codices that were written. The Spanish burned many of them during the colonial era. So for the Maya region, only a handful still exist. And they're primarily related to calendar keeping and ceremonialism and ritual. But these classic Maya stone monuments are really about recording the lives of these elites. So when somebody took somebody captive, they would call themselves, so-and-so of 10 captives. They'd really glorify themselves, and they talk about the defeats of different cities, and I defeated this king. They'd also talk about people coming from further afield, from the large city of Teotihuacan, which is located in basically what's modern day Mexico City today, coming and bringing emissaries in and establishing political connections. So as a way for people to legitimize their rulership by tracing their dynasties, their lineages, they could record events, which we know exact days that they happened because epigraphers have translated these things. So we can say something happened on November 4th, 725. I'm just making that up off the top of my head. But they also told things in the past and in the future. So the earliest date they have is about 3000 BC, and then the latest one is even further in the future, after 2012. 11 years ago now. So there are thousands of records, and epigraphers have spent decades decoding and collating these, and they're brilliant. These people, they can draw glyphs from memory and things like that. There are databases that they analyze to get these types of information. There's a really wonderful book by an epigrapher named Simon Martin, who works at UPenn, so not too far away from here, that called something like Ancient Maya Politics, came out in 2020. It's a book about this that talks all about these connections, and it's a really good read. But yeah, they recorded intimate details of their lives, and we've been able to decipher it, which is amazing for archaeologists.
Hi. Okay. You have hundreds of years of information, or millennia of information, on diet and what people ate. Looking at time a different way, are many of the burials young versus old, or are you looking at what adults ate over time? Do kids have different diets from adults?
Great question, yeah. So a lot of the burials that I showed you are primarily adults. Sometimes the burials of young individuals do not preserve as well. Their bones are smaller, more fragile. Teeth, in fact, are the element that preserve the best because the enamel's hard. The adults, we also tend to have more material to work with as well. So you need, a relatively large piece of bone. You don't need a whole bone, but a piece of bone in order to work with it. That's, changing all the time. We can use smaller and smaller amounts of material, which is great. So at Calpetch, the site that I work at, primarily we have adult interments, but that is not always the case. In some contexts, including many ritual contexts like caves, the ancient Maya associated caves with the watery underworld called Xibalba, we often find the remains of juveniles subadults, people who were 15 years or younger, as sacrifices, often in the context of kind of extreme environmental crisis as well. So what some people have termed the drought cult. So it sort of depends on the context, but we do find the remains of young individuals. Sometimes neonates even are found. It sort of depends on preservational conditions. Your questions about differences in diets, there are differences. It in fact has to do with nitrogen isotopes with meat protein intake. So infants, archaeologically speaking, that's people who are from birth to 4 years of age, tend to have higher nitrogen isotope values, meaning they have higher animal protein intake. That's from nursing, from breastfeeding, and they're getting that from their mothers. So technically, I don't really like to think about it like this, but they're like little carnivores, right? They're also getting the carbon from their mothers eating corn as well. So their isotopic values are compounded. Whatever their mothers are eating, they're getting a portion of that too. And after age 4, that tends to drop off, and young individuals tend to have diets more similar to adults. So it's kind of cool because we can track that through time and see what diets look like for young individuals. We have very, very few really old individuals, partially because people didn't live as long. Also partially because our age estimation methods in archaeology are not great. Usually we get categories like 50 plus based on different changes, physiological changes in bones. But when we do have more precise age estimates for older individuals, it also appears like they tend to eat more corn compared to your kind of young adults, people who are 25 to 30, let's say. And it probably also has to do with changes in health. They're eating kind of more maize-based foods that are softer, easier to chew. Makes a lot of sense. Now, we don't have a huge number of those types of individuals, but we do see dietary differences over the life cycle, which is really interesting. Males also tend to eat more corn and meat than females, just based on these isotopic values too. Not always statistically significant, but a trend that has been noted. So you can look at these different age identities, gender identities, which is really cool using these methods.
Are you able to go back to the last slide, your conclusion slide?
That one?
Yes.
Yeah.
So expanding diets to include wild resources sounds, I struggle because it's possible that because these are fragile ecosystems, if you have a lot of people and all of a sudden you're putting stress by saying, oh, go eat wild resources, it won't be sustainable.
Right. I think what I was sort of getting at is this is what we've seen from the past anyways. So this is what the Maya did. Now, it doesn't make sense for us to go eat wild resources today. Not really. I mean, where are we going to go do that? And I don't know anything about wild foods. But I think the idea is more local food sources that could be through farming, for example, could potentially be an answer to some of these issues, especially in places where subsistence farming is what they do anyways, right? So in places like Central America, where subsistence farming does make up a large portion of the way people get their food. So yeah, maybe not an answer to everything, but.
Yeah. Thank you.
We've got a few more questions from our online audience. We've got a couple here from Virginia. The person, not the state, although she may be in the state for all I know. The first one is, did the Maya evolve from initially hunter-gatherers to primarily farmers? a trajectory that, we've seen happen in, people who lived in what is now the US?
Yeah, so yes and no. People who lived in the Maya region, we do have evidence that they were there prior to settled farming communities. This is primarily based on the presence of different stone points that would have been used for hunting. Now we find similar things at Paleo-Indian and archaic sites in North America as well. But in the Maya region, interestingly enough, before we have settled villages, we have evidence of agriculture. We know that before people are living permanently on the landscape, they are doing some farming. Archaeologists have recorded maize pollen, so domesticated corn pollen in lake sediments dating back to about 3000 or so BC, 4000 BC. There have been some excavations that have also revealed small maize cobs, not our big domesticated maize cobs, but cobs on the way to being domesticated as well. And there has also been a really amazing study of isotopic analyses from southern Belize in the past 5 or so years that they found in 2 rock shelters a burial sequence going back to 7000 BC. So these are some of the earliest burials we know of from Central America in general. And tracking their diet change through time, you can actually see a shift. These people also were not permanently settled on the landscape. So they weren't living in aggregation, at least what we can detect archaeologically. So prior to about 4,000 years ago, the little evidence we have, people were hunting, gathering, fishing, foraging. They weren't growing domesticated crops. But in the Maya region, at least around 4,000 BC, 3,000 BC, that's when we start to see a little bit of evidence for maize consumption. And then by the time we have farming villages around 1000 BC, they are full-blown farmers. So there is that steady progression through time.
And Virginia's other question is, what caused the century of drought that the Maya experienced? And I'll add to that, do we know if that lines up with any other climactic shifts that we saw globally?
Yeah, so that is a question that I think is so interesting. And I'll answer the question about the lining up with different global climatic shifts first. Yes, we see a lot of socio-political changes in the Americas, especially around about 1000 AD, 900 AD. We see the fall of several large empires in South America. The Wari and the Moche disintegrate. We see the decline of Chaco Canyon in the US Southwest. There is a giant drought that has been recorded in tree rings there. But not everybody fared poorly. We actually start to see the growth of Cahokia in just outside of St. Louis, the large chiefdom around that time too. So people are responding to this drought that has been recorded across the Americas in this general time frame in different ways. Now, some climate conditions, climate change is related to general long-term Earth processes like its orbit around the sun, the tilt on its axis, the Earth's wobble, things that happen over millions and millions of years. But one thing that is being looked at right now, and I don't have all the answers to this, my climate scientists colleagues probably would know better about it, but we start to see the stabilization of the El Nino Southern Oscillation. So the ENSO cycle, it didn't always exist in the way that we're kind of familiar with it, where every 7 or seemingly more now years, El Nino comes into effect, and then we see La Nina, where the trade winds in the Pacific kind of shift their intensity. It seems like, I don't know the exact date, but it seems like this type of pattern didn't really stabilize until the past about, I want to say, like in the last 2000 years, it started to stabilize. So it might be related to that. although these things are cyclical, right? So large-scale droughts happen every couple centuries or so. And these probably weren't the anthropogenic kind of climate changes that we're experiencing today, however, at least not in the same kind of magnitude anyways.
Great. If there are any other on-site questions, we can go to our audience members here. Otherwise, we do have a couple more online questions. Kitty Mama has another one for you. Did you find any differences between the diets of women and men?
Yeah. So men tend to eat, based on the isotopic analyses, have more maize intake and more meat intake. This might be because of their social status. So for the Maya, at least, it was a patriarchal society, although there are many examples of Maya queens who were rulers, and we've even have examples of Maya women or females who may have been seen as more warrior figures too. But typically when we look at the population as a whole, males tend to eat more corn and more meat compared to females.
And the last question we have from our online audience is from Pauline. And Pauline wonders what percentage of the society was made up of those elites?
Yeah, so it was a pretty small percent, not exactly the 1% that we think of in our society, but probably about the top 3% were kind of royals related to the kings and queens. Then we have right below that kind of priests and other administrators. So maybe there are another 10 or so percent. We have commoner, merchant class, farmers, and there was a slave class among Maya society as well. Probably not very large, but people who would have been taken captive in times of warfare, things like that. So we did have a pretty hierarchical system. So a little bit more than what we might characterize based on our current knowledge, but the majority were everyday merchants, traders, farmers, that sort of thing.
Right, do we have any remaining questions from the audience? Okay, well, thank you, Dr. Ebert, for coming out. Thank you to our audience for joining us this evening. Next month, we will be hearing from Carla Ng, who will be talking to us about PFAS and their effects on our health and what they are. So please take a moment to come out and join us if you can. Otherwise, have a wonderful evening.
Thank you.
Please make sure to take your trash with you as you go. Thank you.